all these tools, third-party tools, rely on these native tools or built-in tools we have in Postgres. Okay. So this is the more crucial lesson to understand the backup and recovery. If you are good with it, so you can understand others also, because those tools do nothing. They don't do any backup. So these are the core tools which does the backup. Even the third party tools in turn call these tools to perform the backups. Okay. So that is what we have to keep in mind. So, so today, whole day, we will see backup and recovery. So I will explain you and then I will let you guys to perform the backups all by yourself. And recoveries, how to recover, how to back up the database. So we will do so all such things. Okay, so let's go here and so let me check if my, okay, this is running. Okay, fine. Okay, so first of all, the Postgres right now we have in our lab. So that is not what we say means that is not 100% recoverable. So the Postgres, if you take the backup, so till whatever time you have took the backup, right? So till that point, the Postgres is recoverable. But after the backup, if any changes occur, so they are not recoverable in our Postgres. So first of all, we need to concentrate on a topic called as continuous archiving. So the first topic is archiving. So archiving in Postgres is same as archiving in Oracle database. So archiving in Oracle database. So what happens, we have the wall files, right? We have the wall files. Let us visit our lab and check what wall files we have. So these are the current wall files we have. So only one file is there. So only one file is there. So the size of the file is 16 megabytes. That is the size of the file. Okay. So the wall files, or the physical wall files, the technical term in Postgres is wall segments. These wall segments, right now I can see only one, but on production servers, you may have many because nothing is happening on our lab machine, right? So there is no transactions happening, right? On production server, there will be a lot of transactions happening, and you will see a lot of val files here, a lot of val files you will see. Okay, so right now lot of wall segments we don't have, but we have only one wall segment, and each wall segment is about 16 megabytes. So each wall segment is about 16 megabytes. Wall segment. So the size is 16 megabytes. Okay, so when one wall segment fulls means, when it creates the file size will be 15 megabytes, 16 megabytes. When this is full, okay, 16 MB size. So when this val segment is full, so it will write from here. So it will start writing from, the beginning. So when this val file is full, 16 MB, it will add one more val file. Okay. That is also 16 MB. So that is also 16 MB. So it will go on adding the val files. It will go on adding the val files. Each val segment file is 16 megabytes. So each val segment is 16 megabytes. It will go on adding the files. So when this file is full, when the first file is full, so let us say this file is 001. So this file is 002. So when the first file is full, the Postgres can delete that file if all the transactions from that file are checkpointed. If all the transaction from this file is checkpointed, so at any point it can delete that file. So it's its own discretion. So any point of time it can delete that file if all the transactions which are there in the first file are checkpointed. Okay, but this file continues, and maybe on a production server at a time you may have a lot of files. So on production server, you may have a lot of files. The thing is, once a transaction in a particular, all the transactions which are there in a particular val file are checkpointed. So when the transaction gets committed, it is written into the val, and later on, when the checkpoint happens, so from the val segments, the no, so the what we say means. So the changes are written to the data file, and those entries which are done before the checkpoint are not required anymore. So those entries are not required anymore in the val segment files, and Postgres can delete those val segment files anytime. Okay. So what we are telling the Postgres is, so that if you are planning to delete any file, so if you are planning to delete any file, so before deleting, so you copy that file. So before deleting, you copy that file to a different location. So you copy this file to a different location and then delete the file. Okay. So that is what archiving is. If any of the val segment is ready to be deleted, so or it is completed, means all the entries are checkpointed. So that file is archived. Okay, that file is archived. So this is how the val segments are managed. So the total size at any point of time the Postgres maintains is, okay, 1 GB. So the total size of all vals it maintains 1 GB. Okay. So total valve size. So 1 GB. 1 GB is not a hard limit. So, sometimes, even if it reaches 1 GB also, it won't delete the vals. So in replication scenario and in some other scenarios where the vals are required, it will ignore this max val size. Okay. So it will ignore this max val size. You have a parameter which a DBA can configure. So if you want, you can, configure the increase or decrease that 1 GB also. Okay. So here what I am doing is, so PSQL 5433. So show uh, max wall size. So max wall size is 1 GB. So 1 GB max wall size. So the 16, what we say means is MB files. So how many of them I can have? Select 1024 divided by 16. So I can have 64 files at a time. The val segment files may be 64, and sometimes it may be more, because this 1 GB is not a hard limit. Under certain circumstances, it will ignore that max wall size. So it will ignore the max wall size. Okay. So a DBA can also, depending on the site, the DBA can increase or decrease the wall size. Today is which day actually? So I lost the count. Day 8 today is. Okay, so there are the max file. Currently the max wall size is 1 GB. Okay, and each file is about, so about each file is 16 GB fixed size. So we may have 64 val files. So 64 val files. So you can increase or decrease this number 1 GB, you can make it 2 GB, 3 GB. If you see that a lot of transactions are happening per second, so you can make some changes here. So max wall size, you can set the max wall size. So you can set this parameter to suit the site requirement. So, but this 16 MB is fixed, you cannot change it. So, but you can change max wall size. So, however you want. So, when a particular wall segment is about to be, so when a particular wall segment is about to be, what we say means, so discarded, so we can tell, so Postgres to copy that wall segment to a different location. So that is what wall archiving is. So before any wall is about to be deleted, so so we can copy that before deleting, so that wall file can be copied to a different location. So this gives more durability to the server. So you can also recover the transactions which occurred. Okay, you can also recover the transactions which occurred after you took the backup. Even those transactions also can be recovered using what we say means archiving. The archiving concept is 100% same what we have in Oracle database. Only thing is how we do it, it differs. So how we are doing the archiving, it differs, but 100% the concept is same. Okay. So, so this is about, the wall management and wall segments we have. Okay. So all the walls, the walls are maintained, wall segments are maintained in the PG wall directory. So Postgres automatically maintains the wall logs, which are full and switched. Generally, so usually when a wall log is about 16 MB, it will be switched. A new wall segment will be created. So for every 16 MB. So continuous archiving can be set up to keep the copy of the switched wall file. So it also enables online file system backups. There is another advantages. So generally, if you want to do a file system level backup using operating system tools like tar, or tar or zip tool, or so rsync tool, so you cannot do that. But if the archiving is enabled, so you can still be able to perform so file system level backup. This is very, very useful if you are backing up. So if you are backing up Postgres using tools like Commvault, or tools like so Veritas backup. So you can just back up the file system, the data directory we want. We don't want anything else. We want the data directory. Okay, we don't want the executables also, those USR, PGSQL. We don't want those executables. What we want is only data directory and the table space directories. So from file systems, you can directly back up the Postgres using so your Commvault backup tool or your Veritas backup tool. So they work perfectly if archiving is enabled. So not only that Veritas backup, Commvault backup, but also any other backup tool, any other system. So file system backup tools like CPIO or tar, or zip, or you can use rsync, any tool. Okay. So without archiving, recovery of database cluster is possible till the time of backup. So if you have taken the backup now at 2 p.m., if you have taken the backup at 2 p.m., so and at let us say at 4 or 5 p.m. the server has crashed. The recovery is possible only till 2 p.m. if the archiving is not enabled. If the archiving is enabled, the recovery is possible to almost like last transaction. Okay. So archiving allows us to recover those transactions which occurred after the backup. Okay. So so it is like archiving is like the similar term for SQL server about archiving is backing up transaction log backup. In SQL server, we do the lag backup and we will put the database in what we say means full recovery mode, right? So full recovery model. So it is like putting the databases in full recovery model and then taking the log backup. That is equivalent to the archiving. Okay. So it is nothing but the log backup. Archiving is nothing but it's kind of similar to, not exactly same, but similar to log backup. And the benefits are also same. So same benefits what you get with the log backup. So on every production database cluster, archiving must be enabled, because without archiving, you are not able to recover the cluster in event of a crash or failure. So that's the reason archiving is a must. You cannot escape that. You cannot ignore this one. Okay. You cannot ignore this one. Okay. Like in Oracle, archiving is must. I'm not sure what we have in DB2 related to archiving. So, but in SQL Server, archiving is equal to full recovery model plus log backup. In Oracle, archiving is exactly 100% same, like, Postgres server. So in Postgres server, we have this archiving. Okay. So everybody understood the concept of archiving? Any questions we have? Okay, so I am taking that as no questions. Everybody is very good, understood very well. Okay, the wall level. So the wall level, there are three wall levels in Postgres: minimal, replica. So it is the default, and logical. So these are it is the lowest, and this is the highest wall level, and it is the lowest wall level. Okay. So it is the lowest and highest. So lowest wall level is minimal, highest wall level is logical. Okay, three wall levels are there. Okay, so three wall levels are there. So if you are setting archiving, so minimum replica is needed. That is the default wall level. Replica is needed for archiving. Okay, wall level replica is needed for okay, archiving, and that is the default. So there is another thing called as archive mode. Archive mode is right now off, so you need to turn it on. And archive command you have to give. So it can be a Linux command, so you have to give an archive command. Okay. So these are the three settings you need to set. These are the three settings you need to set for archiving. Set up archiving. So what we need is a directory to save archive archived wall segments. So a directory, we need to save the archived wall segments. So this is the first requirement. Second requirement is configuration. Second requirement is configuration. In that, so wall level, wall level. So it can be either replica or logical. So these are the two wall, these are any one of these is required. And by default, it is replica. So that's the reason, we are good here. So the number two, that is, B. So the second configuration thing, what we need is, okay, archive mode. archive mode set to on. So this you need to do. By default, it is off. You need to set it to on. Number C, so that is C, that is third, is archive command. Is equal to, so you have to give an OS command capable of copying files. So there is a, you have to use an OS command which is capable of copying the files. On Linux and Unix, so we have the cp command, we have rsync command. Okay, so we have rsync command, we have cp command, so we have scp command. Okay, these are the commands which are capable of copying the files, right, from one place to another place. Actually, rsync and scp, they can copy the file from one server to another server as well, because the archiving plays a very crucial role. Archiving plays a very crucial role in the recovery. So that's the reason, the archived file, it is always recommended to save the archived file on a different server, because if you lose the production server, your backup and your archive should survive to get back everything properly. So these two things you have to make sure. So you have to make sure that your backup and your archiving, so archived files should survive in event of a crash. So that you can ensure by keeping the backup and archives in a different server. So on Linux, you have these commands: cp command, the copy command of Linux, the rsync command. So if you are not familiar with the rsync command, so you get familiar with it. It's a very powerful and simple to use Linux command. And scp command, so which is also, it is a secure copy. It copies so the files between two servers. Okay, so these are the three commands on Linux, and there could be more commands also. You can write your custom scripts. So, you can have many more things. So, basically, we are giving an OS command which is capable of copying the files. On Windows, on Windows, so we have copy command. So on Windows, so we have a copy command. So I think there is a xcopy command also. So these are the two commands we have on Windows. On Linux, so basically we need a OS command. So the archive command should be an OS command capable of copying the files from one location to another location. Okay, so setting up archiving is very simple. First, you need to create a directory who is which is owned by Postgres user. So the directory must be owned by Postgres user. And the second thing is, you need to do these three configuration. So already wall level is set to replica, so there is no need to touch. So archive mode, you have to turn it on. So, and archive command also you need to set, which could be so any Linux command. So this is what you need to do to set up the archiving. Okay. Any questions here? So there are two literals which can be used provided by Postgres. So one literal is %p, %p. So it indicates pg wall directory. So, PG wall directory in data directory, it has, wherever percentage P comes, that means, PG wall directory. Okay. And there is another literal, so which is percentage F. So the percentage F is wall segment which is about to be, so which is about to be archived or switched. So these two literals are provided by Postgres, which will help with our command. Okay. So percentage P always represent PG wall directory with full path. Okay, which full path, it represent PG wall directory. And percentage F represents, so percentage F represents what we say means so if the wall file which is about to be switched and which needs to be archived. So percentage F is replaced by the wall segment name which is about to be archived. Okay, these are the two literals, so which are okay provided by Postgres. One is to represent the PG wall directory because that is the directory where wall files are saved, and other one is percentage F to represent the name of the file which you are about, which is getting to be what we say means switched. Okay, because the OS copy command required source and destination, right? OS copy command required source and destination. So anyways, this is what we have. And let us go and let us go and let us check so what we can do so about archiving. Okay, so I need to set up archiving. I need to create a directory and I need to set this archive configuration. So you can do it with a so so you can create a directory manually. You need to create a directory. So I'm exiting from here. So pwd, so I am in where live PGSQL directory. So here I am creating a directory. So arch. So the arc directory is where I will save my archive files. Okay. So I am giving chmod 700 arch. So I don't want others to, okay, check that directory or others to, have access to that directory. Okay. So this is what, you can create at any location, but the file permissions and ownership should be same. So I got my directory here. So regarding the configuration, you can do it by, either changing the PostgreSQL.conf file directly, or you can also use alter system command. So you can use any one of these commands. So, I will do it with, directly changing. So wall level is replica already set. There are only two other minimal and logical. So by default, it is replica. So, don't set minimal ever. So, you can go to replica. So if you are configuring logical replication or bidirectional replication, you need the logical level, wall level logical. So wall level logical is needed if you are setting up logical replication or bidirectional replication. So it is the highest val level and minimal is the lowest val level. Okay. So val level is replica. So I'm just uncommenting it. And then the next thing what I need is, so the next thing archive mode. So archive mode right now it is off. That is the default. So also make sure also note that this change requires a restart. Okay. So archive mode is on. And then the next thing is archive command. Archive command does not require a restart. A reload is enough for archive command. So for our reference, it has given a example command also. Okay, this is the example command it has given. Okay, so this is the what we say means where we are archiving archive directory. So I can type that command here. So I'm saying insert test. Okay, this is optional. Test is optional to what we say avoid any duplicate copy. So to avoid any val file being copied twice, so we are using this. Okay. So our file is var live. So PGSQL ARCH. So percentage. So percentage always represent the val segment file name. So which is about to be archived. So if that is not there, means if that file which is about to be archived, not there, not present in the archive location, so then copy it. The Linux command copy. From where we need to copy? From the PG val directory we need to copy. So percentage P is the PG val directory. So that is percentage P is val directory. And where to copy? So copy to var live. So PGSQL ARCH. So percentage F. So this is the archive command I have used. Okay, two Linux commands I have used here. Okay, so two Linux commands I have used here. So one is, to test, to, make sure that, the same archive file is not copied twice. So first of all, it will check whether that file does not exist. If the file does not exist, then it will perform the copy. So if the file which is about to be archived already exists there, it won't perform, it will skip. So that is what, the test is about. It is a Linux command test, you can check out. So, and here, double ampersand I am using, that is also a Linux thing. So you can use this double ampersand between two commands. So if the first command is successful, then only it will execute the second command. Okay. If the first command is unsuccessful, it won't execute the second command. So in our case, the first command, this is test command, will be successful only if the archive which is about to be copied does not exist. Okay. In the archive location. So then we are copying it. Okay. So an example command is given here exactly. You can use it. Only difference what I did, only thing I changed it here is, I changed the location of archive directory. So I have changed the location of archive directory in production environments. So you need to send the archives to another file system, which is a mounted file system, or use rsync instead of cp command. Rsync is capable of copying, and scp command is also capable of copying. So files from one server to another server, use those rsync, and tomorrow we will see about rsync. Anyways, Darman requires that. So, the archive command tomorrow barman requires a change in the archive command. So because barman requires the archive files to be in the barman server. So tomorrow we will see. So we can, instead of CP command, we can also use SCP command and rsync command if you want to copy the archives to the remote server. So these are the three configuration changes we have done, and that is over. So one of the configuration change, that is, archive mode on requires restart. So once we restart, our archiving is set up. Okay. So wall level, archive mode, archive command. So these are the three changes I did in the PostgreSQL.conf file.
Shami, Surya here. Where
Sure.
we are mentioning the archive location, is that at the archive underscore command? That is the location that archives which reside over there.
I will tell you.
Okay.
So here you are mentioning the archive location, right? The directory which I have created earlier.
That is a copy location you said, right? I thought by
That is
default
where
where you put
the
it.
archive is copied to that place.
Okay.
Okay, that is where the archives are copied.
Okay.
Okay. So from PG wall directory, so percentage P represent PG wall, PG underscore wall directory. So we are asking copy from PG wall directory to this archive location.
What is the PG wall directory here?
So PG wall directory, right? So we have this
Mm.
PG wall directory, right? LS, okay, 14 in data. So you have PG wall directory. You can see this one.
Yeah, I can see that. Is it like something
Okay.
physical location or else something like
It's
configuration?
a physical location, right? So it is a
Mm.
directory where, so all our wall segment files, the redo log files are saved. So you are from
Okay.
Oracle or SQL Server background.
Oracle's only. That's
So, wall is nothing but redo log. So it
okay.
is, what we are learning is redo log archiving.
Okay.
Okay. So
Yep.
PG wall is the redo log directory, and these are redo log files. So we call it as wall in Postgres.
Okay.
So redo logs are called as wall, WAL.
Okay. Got it. Thank you.
Okay. So what we are trying to do is setting up the redo log archive. So now you are clear.
Yeah, I'm clear now.
Okay. So because this wall archive mode, enabling archive mode requires you to restart Postgres. You need to restart Postgres. So if we have done everything correctly, so it will restart properly. So it will say server started. So if you have not done anything properly, so if it will give the errors. Okay. So I have changed the PostgreSQL.conf file. So you can also do this configuration change from using the alter system command. Also you can use. So instead of editing the PostgreSQL.conf file, you can also directly run the command. So alter system command. So that would also, so that would also be same. So anyways, my archiving is done. So let us say if there is any archiving, any archived file we have. So right now, no archive file is there, right? So you can see that, archiver is running right now. The archiver is running. This process was not there earlier. So now this process is here, right? So this process is right now running, you can see. Okay, so that means, archiving is running, but we don't have any archive file yet. Why?
There is no transaction, so we don't have any switches over
Yeah, so we don't have any transaction, so we don't have. But there is a function. You can force Postgres to switch the wall. PSQL P5433. So there is a function with which we can force Postgres to switch the wall. Okay. So even before, even it is not needed now. So but still I am asking it to, forcing it to switch the wall. So it has switched the wall. So now you should have something there, right? Okay. So here, I will do now same ls arc. So I should see some files there. So this is because, I have forced the Postgres to switch the wall. Okay, my archiving is working fine correctly. Any questions here? That is about archiving.
Do we have any format to set the archive, like a date, time, instance name, something like that? Parameters is there for that?
Only these three parameters. Wall level, archive mode, archive command. So that's it. So we don't have so many like Oracle. Okay.
Sammy, now this archive mode has been set to the other device also, right? For this instance, for the complete instance.
Completely. Archive walls are common for all databases of that
So
instance.
whatever that other DBs we have, like MySQL, that we created other DBs. So for that also, this
MyDB,
archive
right?
mode is be, it got
MyDB.
created. It got enabled now by
Yeah,
default.
the wall and archive, the wall is common for all databases in Postgres. So
Correct.
one instance of Postgres has many databases. Wall is common for all. So you are from SQL Server background?
Oracle.
Oracle. Yeah, in Oracle and SQL Server, every database will have their own redo logs, right? Transaction log.
Correct. Correct.
Yeah, here, this is a common thing, common resource for all
Correct.
databases.
Redo logs okay. Archives also it is shared, right? So now when we
If
on this
redo log
turn
is
on
shared,
this.
archive. Okay, the thing is, if redo log is shared, archive is also shared, right?
Correct, correct. So for the other DBs also, this got enabled by default now.
For everybody, it is an instance level enabling.
Okay, okay.
Okay. So, that is the major difference between, it is like the old Oracle database, you have the
Exactly,
11
exactly,
version.
exactly.
So, in old Oracle, we don't have databases, right? So we only
Correct,
have the schemas. So,
correct.
but here we have databases. So, this is common resource for all databases.
Okay.
Okay. Any other questions? So that's the reason, the recovery, you cannot do one database recovery. So if you are performing the recovery, right, you have to perform the recovery for all databases. So in SQL Server, in latest Oracle, so when you have multiple tenant databases, so you can perform the recoveries for individual databases, right? So here it is not possible. You have your employees database, you have maybe having some other DVD rental database. So recovery is possible for entire instance. It is not possible for one single database. So these are some restrictions, or these are some drawbacks or restrictions or limitations, whatever word you use. Okay. But these are some of the limitations we have here for recoveries. Got it?
Yeah, we do have options to recover data, data file level. That options are there, right? Like Oracle, we have, right? We can recover only the data files and only the table like that. We have anything
No,
option
we
like
don't have options. We don't have option. Every table will have its own data file, right?
yeah.
So, we don't have a shared collective data file for many tables and indexes. Every index and table will have its own data file here. So individual data file recovery is not possible. So, it is not same like, Oracle with all features, right? So, it is Postgres.
Yeah, got it.
Okay. So, but whatever thing you asked, right? Page level recoveries we can perform. So data file recoveries we can perform. So single database recovery we can perform. So these things are not possible here. Okay. So here in the PDF I have given, so alter system command, no, I have not given any command at all. So, I directly ask change it in Postgres or using alter system. We have option. So you can use any one of these. Okay, so this is how this is how you can do the archiving. Now, once we set up the archiving, we will talk about the backups, right? So we'll talk about the backups once we set up the archiving. So there are three different backup approaches we have in Postgres. Built in, these are. So these are, with the Postgres, they comes with Postgres. Okay, they are PG based backup, cold file system level backup, hot file system level backup. PG based backup is the backup tool, recommended backup tool for Postgres. So this is the only backup tool which is shipped by Postgres. Okay, whether it is, enterprise version or whether it is community version, this is the backup tool. You have PG based backup. Okay. Cold file system level backup means okay.
I have another one question. Uh, is this backup that happened like in Oracle? It will happen as block by block, right? So how it will it was there in the Postgres?
We will discuss that.
Okay.
So we have this base backup. So the base backup, and you have file system backup. So base backup is done with a tool called as PG underscore base underscore backup. So it is a tool, and file system level backups. So in file system level backups, we have two: cold backup and hot backup. I think you can. What is cold backup? I think you know that hot backup and cold backup, right?
Yeah, it is a consistent and inconsistent backup.
Yeah, cold backup means Cold backup means stop service and perform backup. Okay. So hot backup means so backup while the service is running. Service is running, perform backups. Okay, while service is running, perform the backup. So that is hot backups. So in file system level backups, what we backup? So file system level backup. So we backup data directory, all table space directories. So data directory and all table space directories we need to backup. Okay, file system level backup. Whether you are doing hot or cold, so irrespective of that, you can use data directory and file system level backups. So the tools which can be used for file system level backup are so you can use OS commands. So like tar, okay, zip, etc. And you can use external backup tools. Enterprise backup tools like Veritas, Commvault. So you can use for file system backup, right? You can use the tar command. So you can use zip command. You can use other OS provided commands, or you can use, the enterprise backup tools like Veritas, Commvault. So, the Commvault and Veritas are most commonly used backup tools, or any other backup tool which is capable of backing up a file system, right? A directory. So, and its files. So you can use any of that. Okay. The tools like Veritas and Commvault, they are very useful tools because you can do incremental differential backups. You can do a lot type of backups with that. So that is what you know the tools you have for file system level backup. So file system level core backup, the tools we Postgres does not provide. Postgres provide one tool called as base backup. This is the only tool Postgres provides for backing up. Okay, so that is the only backup tool we have in Postgres. Okay. So, however, you can use, hard backup, hard file system backups are possible. So you can use Veritas or Commvault. So Veritas Enterprise Backup or Commvault backup tool to perform hard file system level backups. Okay. So they can be done, hard file system level backups also. Okay. Or cold backups also you can do. So this is what the backup picture we have. Any questions we have here? Remember, even the other tools, enterprise tools like BART or Barman or PG Backrest, some backup tools are there, third party backup tools. They also relies on this mechanism, archive mechanism, and the file system backup mechanism and PG based backup. So they don't bring any of their own mechanism to do the backup, because backup means the tool should understand the Postgres very well. The tool should be able to understand the Postgres very well. Third party tools will not be able to understand the database. They will not be able to back up properly. So, that's the reason those tools also in turn calls this base backup, in turn calls this, so archiving. So they in turn call these tools, which are built in into, are shipped with Postgres. So anyways, we will see how we can perform the backup. We will start with base backup as it is the recommended tool. Okay. The Postgres community recommends base backup tool. Okay. So, but most practically the industry people use hard file system backup using Veritas or Commvault. That is what, practically many people uses, because it is very convenient for them. They can integrate it very easily into their existing backup. So existing backup, process, right? So every company have this either Veritas or Commvault or some other kind of backup. Every company has enterprise backup tool. So, it can be integrated very easily. So for Postgres also. So many companies use this file system hard backup using the Veritas or Commvault, because, they can perform the recoveries and all so very easily with it. So anyway, they can perform the what we say means recommend, so incremental and differential backup. The PG based backup tool, on other hand, cannot do any incremental backups. So this tool, no incremental backups for this tool, only full backup. Anytime you backup, it will do a complete backup, PG based backup, and this is the tool which is shipped. Okay, this is the tool which is shipped with Postgres. Okay, any questions here? Anyways, the PG base backup tool. So this tool, PG base backup tool, works as if it is a replica. Okay. So it will connect to Postgres server as a replica. So now we'll see about PG base backup. So PG base backup. So this tool acts as replica, connects to Postgres as replica. Okay. So then it will perform the backups, can perform remote backups. So you can perform remote backups from one server to another server. You can pull the data. So from Postgres server, you can dedicate one server for backups, and you can pull the data from Postgres server to that. Okay. So this is part of, the client package. So remote backups are possible. Okay. So the downside is no incremental or differential backups. No incremental or differential backups. So that is what, that is what the limitation of this tool is. Otherwise, it is a perfect tool to back up Postgres. So why we need to look for other tools like Barman or something is because it does not have the capability of doing incremental backups. Okay. So remote backups, it can do connect to Postgres as replica. So how it connects, it is not a big deal. So it cannot do incremental or differential backup. That is the biggest what we say means limitation. So that is the reason we have to look for tools like Barman, Bart, and other tools. Okay. Okay, that is about our PG based backup, how it comes. So I will show you one example. So it connects as a replica. So we need a replication connection here. Replication connection entry in hba.conf file. Okay. Needs a user with replication attribute. So the user which is about to so the user which is going to connect, so it will connect with the that user should have replication attribute. Okay, just a minute. Hello. Yes. Yes. Oh, I saw your colleagues, that one, control them. So that's, the lab problems are there. So it is not doable. Yeah. You can check with vendors. I don't know any vendor who is providing the lab for control. Okay, I will share in the evening. Right now, I'm in the session. Sorry for that. Okay. So, a user needs a replication attribute. So one of the user attributes like super user is attribute, create role, create DB. So these are the attributes, right? One of the attribute is replication. So the user which you are going to use to what we say means perform the backup using base backup. So requires that attribute. Our super user also works. So, the val level should be minimum replica or logical. I think we are good with val level. Val senders. Okay. So should be more than one. Okay. Val senders means, we need one val sender for each replica, each standby. So, if you have 5 standbys, you need 5 Mac val senders. So that is what val senders are. Okay, each replica that is standby requires a val sender. Okay, so PG based backup connects to Postgres as a replica or standby. So it also needs a val sender. Okay, so val sender slot. So we will check how many val senders slots we have. So max val senders. So we have 10 perfectly good. So we can go with, so, about, lot of replicas as well as, many instances of PG based backup running. So 10 val senders we have. So PG based backup tool. So, and val level is replica already we are sure about it. So val level is replica. So because for archiving, we did that, right? So okay, so then we can go ahead and perform some backup. So do we have any users with replication? So we don't have any user who has, the replication except the Postgres user. So we can use Postgres user to perform the base backup. Okay. So we can use Postgres user. If you want to have a dedicated user, so then you need to create a user with replication attribute. That is enough. No other permissions are needed. Okay. You create a user with replication attribute, that user will be able to do it. Let me create a user. Create user base backup. Okay. So with, okay, login with replication and password. So I can use the password like, secret. So this is what, I have created a user, this, I could have used the Postgres user also. Okay. So we also need a entry in the hba.conf file. Okay. So, we don't have any entry for replication here, right? So we don't have any replication entry. We need to add a replication entry here. Okay, so I am saying local database. Backup is for all databases. It is not for a particular database. You cannot back up one single database. So which database, we are saying replication. Okay. User is base BKP. That is the user I have just created. Address, no address for local. And the password is spam sharp 256. You can also use trust also. Then it won't ask for password. Post replication base BKP all. Okay. So these are the two. One more entry I want to add here for replication. So for Postgres user, it is a local and it is peer. So without password. So, this just like that I have added because Postgres user is also there. So, but local, this is I have added for base backup user. Okay. Oh, I need to put this, these reject are there, right? So I need to put these 3 lines above that reject. So I will just cut it and paste it here. Okay. So, I got them, all three of them I got. If I had put after reject, right, it would never come to that point. Before that only it gets rejected. So anyways, so my file is okay. So pghba.conf file, I made the entries. So, WQ, write and exit. So these are the three entries I made in that file. Okay, these are the three entries I made in that file. I need to reload the service. So I need to reload the service. Once the service is reloaded, so I am good to perform the backups. Okay. So to save the backup, I need a directory, right? Some directory I need. So, in 14, so already there is a directory is provided to us. Right now, there is nothing in that directory. We can use this directory. So we can use this directory. So the other thing is when you are doing the base backup, so it will back up you have to back up the data directory plus, all the table space directories also you need to back up. So you need to back up the data directory and table space directories also. So what table spaces we have? So we have my TBS table space, right? So this tables, my TS table space is there. PSQL -P5433. So you check DB. So I have, this my TS table space, which is at this directory. Okay. So my data directory is a data directory. So I need to make a provision for both the data directory as well as, I need to back up the table space directory. You cannot back up, either one of them. So you have to back up all of them at once. So all of them at once you need to back up. So what I am going to do is, so in that directory, so backups, okay, right now nothing is there. So I am creating subdirectories here. mkdir, okay, mkdir base and, my tbs. So these two directories I am creating and then you check. So these two directories got created. So we need to create a directory. So to save the backup, create directories, not a directory. So we need to create a directory and, one each for, so So I have only one, what we say means table space. That's the reason I have created only one directory for table space. So for base, that is the main backup. So that is, so that is base. Two directories I have created. So I will save everything in there. So, the command to do the backup is very simple. So always it will do full backup. No, no, what we say means incremental or differential partial backups are possible with PG based backup tool. No partial backups, no incremental differential backups. So it is full backups. Always it is full backup. So, let me run the command PG base backup. Okay. You need to give the user the port to 5433 and the user is base BKP. This is the user I am using. Okay. And where to save the backup, where the backup needs to be saved. So where live PGSQL 14, okay, backup base. So this is where the backup needs to be saved. Okay. And we have table spaces also. So the table spaces are right now, so we have a table space where live PGSQL, okay, my TBS. So this is the table space we have. So is equal to where live PGSQL. So 14 backup, okay, my TBS. So we have created that directory. And this requires no spaces. If you give spaces, it will throw errors. So for each table space, you need dash T here. So for my first table space, I had given. So if I have one more table space, I need to give one more T and I need to give. So, the source where the current table space directory is and where you want to back up that directory. Okay. So, after T, for table space, I had given the current table space directory and where I need to back up that current, so that table space directories. So this is the current directory of the table space and this is the backup directory of the table space. So, I am making use of that, the backup full directory which is given. So in production environments, generally we do it on a third server. So PG based backup can connect to remote Postgres and it can backup. Okay. So, generally we back up from the remote servers. This, this is the recommended tool by Postgres community. So you also have one option P. The option P will show the progress messages, what is happening, how much percentage has completed. So that progress will come if you use dash P. If you don't use P, it will do it quietly. So, that we don't want, right? So we want to see some progress. So to assure ourselves that something has happened. It is asking for the password of base backup. So I am giving secret. So you see, the user which I have created requires only a replication attribute. It does not require any grants. So remember, so and we are able to complete the back table means complete the backup also. So this particular message, the progress message came because of this dash P option. If you back up without the dash P option, you won't see these messages. It will do it quietly. Okay. So sometimes, we may get confused. So, whether backup has happened or not. So it is a very first time. So if you are done for some time, few times, right? So then you will be confident and then you don't need to use this P anymore. So, that is optional. P is optional. This is how you can take the backup. So it's very simple and easy and it is always a full backup. Any questions we have? So any questions we have? I'm taking that as no questions because it is very straightforward. You guys have used so Rman and also compared to Rman, this is nothing, right? So this is nothing. So it takes about some time, if you are doing. So I'm explaining and I am doing. That's the reason it took about 40 minutes so far. Otherwise, it will take about 10 minutes. Okay, to create that one-time user creation, directory creation, and all. Anyways, so that is how you can take the backup. Okay. So this is the command. So this is the command pg base backup d. So okay. So the target backup directory. So this target backup directory must be owned by Postgres user. Let's verify what we got there, and then we go to the hard file system level backup. Okay. So you go to the 14 backup. So you have these two directories. Go into base. So you have exact copy of your data directory here. So you go to, the my TBS. So here you will have exact copy of your table space directory. So it will do a file system copy only, the PG base backup. So somehow it will do file system copy only. Okay. So this is what, you perform the base backup. Now we will see file system level hard backups. So before we go, any questions regarding base backup? File system level hard backups. Okay, so what I will do is, so here what I will do is, so I will use the tar command. Command to perform that backup. Okay, we'll use the Linux tar command. Okay, so using Linux tar command we need. So so what are the pre-requirements for this one? Is no pre-requirement because it is done from file system. So no Postgres or database user is needed because it is completely done from the file system, right? However, you need to do something in the database. So for that, you need the super user. Okay. So you only so super user. Actually, taking the backup does not require a database user, but before you start the backup, so you have to perform a checkpoint, and you need to. So what we say means. So you need to perform the checkpoints, and also that is the reason a super user is needed for that. So what you need to do is step number one. So you need to run a command in the Postgres called as pg start underscore backup. So this function you need to run, and then in step number two, okay, we use Linux star command. So Linux star command or you can use rsync, cpio, whichever Linux command, or Veritas backup or Commvault backup. So the step number 2 can be anything. It can be tar command, it can be rsync command, it can be, the cp command, it can be scp command. Okay. So cp or scp, it can be Veritas backup. Okay. Or Commvault backup. Commvault backup. Anything. So step number 3 is, once you have finished the backup, you need to say pg stop backup. So, first you need to say, tell the Postgres that you are about to start the file system level backup. So then, once that is successfully, you execute this function, you do your backup your own way. Veritas, Commvault, tar command, any command you can use. And then last one is stop backup. So I am going to use tar command in our example. So this is what, and to execute pg start backup, so you require, special permissions you require. So normal users cannot do that. Okay. So let me what we say means, so let me start. Normal users also can execute pg start backup and pg stop backup, but they need execute privilege. So these two functions does not have execute privilege to public. So unless and until you explicitly grant privileges to means the user, so user will not be able to do that pg start and pg stop backup. So if you want to use any normal user, that user should be granted. So execute permission on pg start backup function and pg stop backup function. So let us do this. So I need to first do a start backup. So I am connecting to Postgres, any database you can connect. So then you run pg underscore start underscore backup. So you need to give a label. So that label has no significance. It is not written in any backup or anywhere. So it is only that during the backup time, during this time, so the backup runs, so anybody can identify, okay, so what is happening. Okay. So I ran the pg start backup. So once I have done it, so a checkpoint is performed, and I will exit from here. So I will go to my data directory, like PGSQL. So 14. So my data directory is here. So I will just tar this. Tar TF. I can also use vverbose also, but it shows a lot of messages. I don't want that messages. So I want it to do quietly. Data.tar. Okay. So this data directory. That's it. You can use zip. You can use rsync and other commands also. Okay. I also need to tar So I also need to tar this my TBS directory. So this is our what we say means table space directory individually. So you need to individually you need to tar the data directory and every table space, each table space directory. Okay, so that is done. Okay. So my backup is over. So once my backup is over, what I need to do is I need to go and tell Postgres that I am done backing up. So I need to log into the Postgres one more time and I have to say stop backup. Okay. All the required vaults have been archived. It will perform the archiving. So during the backup time, whatever wall is generated, that is archived. Okay. So that, we have the wall in archiving. So this is what needed for, file system level backup. So, so that thing we did with the tar, right? So, you can do it with tar command or like I said, any other command like Veritas backup or, any other command. Okay. So that is how we can take our backups. So if you have file system level backups, so hard file system level backups. Okay. So this is not file system, but it is hard file system level backup. Okay. So you can take hard file system level backup like this. So cold file system level backup, how can I take? Same procedure, only thing is you need to stop the service first, then you need to take the backup of the data directory, and you need to take the backup of each table space directory. So that is how you can take the backup of cold file systems. Any questions here? So that is what, the built-in backup mechanisms we have in Postgres. Hot file system level backup, PG base backup, that is also hot file system level backup. So, and the PG hot file system level backup using operating system tools. So, okay. So, and cold file system level backup is just stop the service and do whatever I did for hard file system level backup. So these are the options, backup options we have in Postgres. Any questions you have, so you can ask me right now. Okay. So I am taking that as no questions, and obviously, so no questions at all. Okay, guys, hope I am audible now. So what happened is my internet got dropped. So I reconnected.
Yeah, we can hear you.
Okay, great. So I need to share this. Okay, screen is also shared, right?
Yeah, it's shared.
Yeah, it's shared. Okay. So any questions regarding how to backup? So I'm sure no questions, right? Okay. So that is what, there is, it is pretty much straightforward. It is not like a complicated tool like Orman, right? So, it's very straightforward and very simple. So keep it simple. So now what we do is recoveries. So I have not demonstrated how to do cold file system backup. Okay. So I think you guys can do it, right? Or do you need a demonstration for that? I think you guys can do it. So you guys can do it by yourself. So I'm going to the next topic, that is recoveries. Okay. So how to perform the recoveries? So I have given this, cold file system backup, how you can do. So restoring from file system backups. How you can restore from file system backup is, so the entire restore process is done from operating system. You don't have a command to restore. So there is no restore command. Okay. So there is no restore command at all. So entire thing is done from the file system, operating system. Okay. So what we'll do now is I will show you the recovery. So of whatever backup we have taken, then I will also show you the point in time recovery post our break. Okay. So before going to the break, we have another 11 minutes. I will show you the recovery. So how to perform the recovery. Okay. So let us say, assume that our Postgres is down. Okay. So our Postgres is down and it is not recoverable. So our Postgres is down and it is not recoverable at all. So that is it is not starting. It is not recoverable. This is the situation where you need to recover from the file system backups. So this is the only situation where you need to recover from file system level backups. So that, the Postgres service is not starting, it is corrupted. Okay. The only way to get back the database online is to recover from the backup. Okay. So this time we are recovering whatever we have in the backup. That's it. So we are not recovering. So we are not doing the full recovery. Okay. So, full recoveries, if you just want to recover from whatever you have in the backup, so you need to use the PG based backup because, that is consistent. The file system level backup we did is not consistent at all. So you need to perform the recovery also for that. You need to perform the recovery also for that. Okay. So, the recovery is done whether it is a file system level backup you have taken using tar or PG based backup. So the recovery is done completely from operating system. Okay. So recovery commands are not there in Postgres. We don't have any recovery commands in Postgres. So I hope everybody is so good with that, right? Okay. So what I am going to do here is, so I have stopped my Postgres. So you need to empty that data directory. You need to empty the data directory. Okay, go into the data directory. Okay. Okay. So you just need to empty this entire data directory. So what I'm going to do is I'm going to say rm-rf. So, so So give a star also compulsory. Otherwise, it will delete the data directory itself. So you have to empty whether you are performing that this process is same for all. So whether even with the barman also, this is the process you need to do. So mostly barman has a command to perform the recovery. Okay. But this emptying the data directory and also you need to empty. So you need to empty your table space directory. Okay. So your table space. So, so you can check out. So where live PGSQL 14 data. So it should be empty. And your, table space directory should also be empty. So both of them are empty, right? So now you can perform the recovery. Current data directory and all table space directories needs to be emptied. So once we have done, so this, so once you have emptied it, so then you can perform the recovery. You can use any of the operating command system commands. So I am using the option P of CP command to preserve the permissions and ownership, and R command to recursively copy. I think small r or capital R something will work. Okay, so if it didn't work, we use the small r. So where is our backup? So our backup is in where live. So PGSQL. So PGSQL 14 backup. Okay, data. So base star. Okay, so this is where we have the backup and where it needs to be copied, where live PGSQL. So 14 and data, it needs to be copied under 14 and data. So this is what, including the permissions and ownership, we have to preserve. So, so let us run this command. So it will copy the content of the backups we have taken. So to that directory, and then we will copy our what we say means. So our work, P capital or work, where live PGSQL. So 14 backup my TBS star to where live. So PGSQL. Okay, my TBS. Okay, both of them are copied. Let us see if the copy has worked perfectly or not. Okay, the tar backup you cannot recover like this the way, because the tar backup so is not consistent. You have to apply the archive log also. You have to perform the recovery. Post break, we will see that as well. Okay. Base backup is consistent backup. So it does not require, you to apply the archives. So, but it will only recover till the time of the backup. So you can also apply the archives on base backup also. So this is what I have done. So once we will verify to be sure, where live PGSQL 14, okay, data. So everything has come back. So I think that will also come back, no issues. My TBS. So the only thing is I'm concerned about, only thing I'm concerned about is the preserve, the P will work, I am sure. So the R was, I was having that out. So everything has come, okay, recursively. So to be more sure, you can also use this PG base. See, okay. So 16. So you have all the files, no issues at all. So verify. So that is it. Recovery means you copy back all the files to the data directory and respective table space directories. So, and you are done recovering. So you are done recovering. So what I need to do next is I just need to start the service. Yes, started. So that is how you can perform the recovery. So without applying the archive logs. So this recovery is without applying the archive logs. So that means anything which is new transactions happened after the backup. So they are not captured by this recovery. Okay, how to do that? So we'll go to the break and we will come back and we will learn about that also. Any questions you have, you can ask me right now. So we will take our break. Still 4:15 and we will come back. Hope everyone is back. Now we will perform recovery. So now then we will perform the recovery with applying the archives. So we will perform the recovery with applying, and also we will apply the archives. So what we will do is, we will go with a plan. So we'll go with a plan. So what we will do here is, so we take a backup, or we can use the existing backups also. Okay. So that is step number one. Step number two is, so we take a backup and, step number two is after backup, we will make changes to the tables. So these changes will not be there in the backup. Okay. So these changes will not be there in the backup. So they will be there either in the vaults or in the archives, right? So that is what, these changes will not be there in the backup. So then number three, we crash the server. So after taking the backup, we'll take the backup, then we'll make changes because these changes are not there in the backup. So these changes will be either there in the val or archives. Okay. So, then we crash and we crash Postgres. Number four, restore from backup and perform archive archive. Okay, this is what we do. So the plan, how the plan is, everybody is okay with the plan. So you want any changes? So what is your opinion? Everybody is okay with this plan?
Yes.
Yes. Okay, so everybody clear, right? So we take a backup. After that, we will make some changes to the tables. So these changes which we are doing after backup will not be there from in the backup. So, but we should be able to restore these changes also. So what we do is we perform the restore from backup, and then we perform the recovery from the archives. So this is what we are going to do. And after completing, if we see, so whatever changes we did in the step number two, so those changes should survive, right? We should be able to recover these changes. So then we can say everything we are able to perform the recoveries. So I will do this, I will demonstrate this, and then, we will go for the lab. Each of you will be doing enabling the archiving. Each of you will be, what we say means, performing the base backup, performing the, file system level backups, hot file system level backups. And then each of you will be performing the recovery. Same plan you will be doing in your lab also. Okay. So that is the plan right now. Okay. That is the plan right now. So, we have our Postgres. So we have our Postgres here. So you're not here. So where is our lab? So this is our lab. And, so we go here. So PSQL-P5433. So we have our tables here. So these many tables are there. So I'll take a backup of all these tables. So you can choose whichever backup you like, whether you like a base backup or whether you like a, the file system backup, hot file system backup. So whichever backup you took, so you can apply the logs without any problem. So, we have our data. So I will connect to my DB also, and I will check, okay, tables here. So there should be a table in SCART schema also. So let me check the table in SCART schema. So SCART schema has T1 table and public schema has test table in my DB. So in Postgres, so we have these tables and so we don't have in, okay, we have sales schema is here. Okay, there is a invoice table in sales schema. So anyways, everything we want the recovery of everything, and also whatever we changes we did, right? So those changes also we need. So what I will do, already we have backups, right? So before going to the break, we took the backup, base backup we took, and we took the tar backup also. You can use either of these backups, whichever you want. Okay. So what I am going to do, so the first step is done here. I am not performing backup one more time. So our backup is already done, right? Already we have the backup, right? So already we have the backup. So we can use the existing backups. And actually we have two options also. We have the tar backup we took and we have base backup, and either of them will be helpful here to apply the logs. Any one of them you can use to apply the logs. So, after backup, we will make some changes. We will start from here. So we will make some changes to the database. So what change I want to do? So one or two changes you do one change in the what we say means Postgres, one change in my DB database. Okay, there is nothing in the orders database. I will insert two rows. Insert into orders, values, so three rows I have inserted. Right, these are the changes I have done. Right. Okay. So okay. So I am making some changes in PostgreSDB and also I am making some changes in MyDB. So, this is what I have done changes into the PostgreSDB. So for MyDB, so I will connect to MyDB and there also I will do a change. So what we have here is, so SCART schema is there. Event table, select star from SCART.t1. So I will do one change here. Maybe one delete or update I will perform. Any change. So because already we did insert, right? So I will update SCART.t1. So because I am Postgres user now, super user, I can do anything. So set ID is equal to, so 25, where ID is equal to 20. So this one change I am doing. So, so this one change I did. In my DB. So when I perform the recovery, so I want these changes. So I want these changes back. Okay. So, okay. And recover. Apply archives. So we will do these things. Okay. So this is, everything is same as we did earlier for restoration. So only some changes I will do so that Postgres can apply the archives. Okay. So, if you want Postgres to apply the archive, you have to force Postgres to go into the recovery mode at the startup. So at the startup, you have to force Postgres to go into the recovery mode. Then the Postgres will go into the recovery mode and it will apply, okay, the changes. Okay, it will apply the changes. Okay. So, now we will do all these things, crash the server, recover, and apply archives. We will use the term restore. So apply archives, restore and apply archives. Okay. So our change, what we did, so, it might be in archive or it might not be in archive at this time, right? The archive, it will go into the archive when, 16 MB worth of transaction is done. So it could be right now in the archive, or right now it might not be in the archive, right? Usually the last minute transactions will not be there in archive. Usually the last minute transactions will not go into the archive, right? So that is what, that is what always you have to keep in mind. The last minute transactions won't go into the archive. Okay. So at least, even on a busy server, it takes about a minute or two to, fulfill what that 16 MB file, right? At least a minute it will take to complete that 16 MB file. So archiving, the last minute transaction, we cannot guarantee whether those transactions are there in archive or not. So how to recover the entire database? So we will see how to recover the entire database. We will see. So anyhow, exit from here. So exit from here. So I will write down the steps for recovery. Okay, this is the problem, and I will write the solution also. So I will use the green color for solution. Okay. So number two is inserted 3 rows in PostgreSDB. So this we did. Okay. So what we are going to do now, the recovery part. So that is what, we do the recovery part now. First of all, stop PG service. Number two is, so, always remember, even in the production environment also, always remember to preserve, okay, the PG wall directory, because, the PG wall directory will have the latest. So the latest transaction, the last minute transactions before the crash will be there in the PG wall directory, not in the archive directory. So from a transaction to go into the archive, a file to get archived, it takes some time, maybe 3-4 minutes. Even on a busy server, it will take 1 or 2 minutes. If a server like our lab, so it will take hours together, maybe days together, right? So, that we have to always keep in mind. So that is the reason, okay, preserve the PG wall directory, okay. So preserve the or backup the PG wall directory. PG wall directory after crash. Always, even in the production environment, when a crash happens, you need to do this. So if you are able to get that PG wall directory, none of the transactions will be lost. Every committed transaction will be there. So if you are not able to retrieve that PG wall directory after the crash means, so you will be good until, the transactions which are archived. So those transactions which are not archived, so, you will not be able to recover them. So, back up the PG wall directory. So after crash, okay, number three is restore from backup and remove PG wall which came from backup. So from the backup, whatever PG wall came, so you need to remove it. So number four is, number four is PostgreSQL.conf file. And number five is yes, that's it. So only thing is, here two things we are doing extra. One is, from the crashed site. So we are backing up the PG wall directory because it will have the last minute transactions. And, we also, okay, we will restore from the backup. After restore, we did this is same what we did in the last before going to the break. So after that, we will also delete the PG wall directory and uh, restore from the PG wall preserved in the step 2. Step 2. So in step 2, so the PG wall we preserved, right? So we will also copy back. So start PG service. That's it. So only thing here what we need to learn is, how to set the recovery configuration. So this is what, we need to check on the recovery configuration. So I will go over this recovery configuration also. Okay. So, I will launch. In recovery configuration, we have two things to do. So they are, the restore command. So restore command option we have to set. And I think that is the only option we need to set. Okay. So the restore command is the only command. Recovery target timeline latest. So recovery target action shutdown. So these are all, by default. So we don't need to give the recovery target time unless and until you want to recover only for a particular time period, you can give. So if you want to start the recovery at this time, so you can give, otherwise don't give anything, it should be null. So the only thing what we need to do is restore command here, restore command. So which is exactly opposite of our, the archive command. The archive command we had given earlier today, right? So the restore command is exact opposite to the archive command. Okay. So that is what the recovery target timeline is. The latest, latest means restore till the last transaction, which is available either in the archives or from the restored PG wall directory from the crash site. Okay. So, recovery target action, you don't do, it will do nothing. So you can do shutdown here. So, but it does nothing actually. Okay. So recovery target time is, if you don't want, you have to give either this one or this one. So recovery target timeline or, recovery target time. So, recovery target time. So you have to give a date and time. Recovery will be performed up until that time. Up until that time, recovery will be performed. Okay. So for point in time recovery, only thing is you are giving recovery target time. So it will perform the point in time recovery. Otherwise, it will go with the latest. This is the default. So recovery target timeline is latest. That is the default. Okay. So if this is not mentioned, if this recovery target time is not mentioned, so it will perform the full recovery. So both from, the archives, it will read the archives, and also it will. So if the PG wall is preserved, so it will also apply so from the PG wall also. Okay. So that is what, these are the options you have to mention. So here we are going with the recovery target timeline is equal to latest. So this is one. So this is the recovery configuration. And one more thing is needed. So that is create an empty file in data directory named recovery.signal. So this file is the one which triggers the Postgres into the recovery. The configuration does not trigger the Postgres to recovery. Okay. So, but the existence of recovery.signal file triggers the Postgres to recovery. So this file, if it is present at the startup, so in the data directory, the Postgres will go into the recovery, and then it will read the restore command. Until then, it does not read the restore command. What is our restore command? So, the copy from, where, so live PGSQL, so ARCH, so percentage AF, so and percentage P is the wall directory. This is our exact opposite of the archive command is restore command. Okay, exact opposite of that one. Okay, so in restore command, first we give the percentage P, then we give this one. So now we are giving the archive location first because it is the source, and the wall directory location last because that archive file needs to be copied back to wall directory. Okay. So this is what the configuration we need, and an empty recovery.signal file we need. So, the restore, the configuration, recovery configuration PostgreSQL does not read unless the recovery.signal file is present in the data directory when the Postgres is started. Okay. So this will force the Postgres to go into the recovery and then restore from the archives. If archive, the restore command is set. Otherwise, if the restore command is not set, it will do nothing. Okay, it will do nothing. So hope everyone is clear about what I'm going to do, right? Okay, so this thing is over. So changes are done, right? So after backup, we made some changes as well. So this is done. So now I have to crash Postgres. So that is, from here I need to jump. So PGCTL stop. So I crash the Postgres. Okay. So backup PG valve from crash site. So I will go to the data directory. From the crash site, the PG wall directory, right? So I am going to copy that or move PG, okay, to where live PGSQL. I'm moving it out of it. Okay. So this is how I have, from the crash site, I am able to back up. So the PG wall directory. So generally, those who are from SQL Server background, they will perform the tail log backup, right, for recoveries. Okay. So, it is exactly same what I did with the PG wall right now. I did a tail log backup. Okay. So, that is what, I did. So because, the wall directory from the crash site will have the latest transactions. So we can recover those latest transactions also. So rest of the process is same. So, you are just emptying this directory. So, the rest of the process is same. So you are just emptying the data directory. You are emptying the, what we say means, so table space directory. So you are emptying these directories. Okay. So once you have emptied these directories, you can what we say means recover. Okay. So you can recover. We have two backups. We have the backup taken with the base backup, and we have the backup taken with the tar command. So both of them are eligible. So which one you want to use? Anybody? We can use any one of them. So there is no preference at all here. Okay. So any suggestion in which one you want to use? Tar backup we took, that one we want to use, or the base backup we already performed one time recovery with the base backup, right? So we have two options, anyone you can use. I will go with the tar backup this time. So I will show you how to perform the, how to do that with tar backup. So what I am going to do is I'm going to say tar hyphen x for extract f. So my TBS tar. So I'm extracting this. Okay. So now you say my TBS. So we got back everything. So this time I am using the tar backup, right? So to restore actually. So, it is up to us, whichever you want. So first I recovered the table space. Then I will go into the, what we say means data directory, and I will restore the data directory. Tar hyphen xf, that is x for extract. File is data.tar. Okay. Now you check the data directory, everything is restored. This PG wall which is restored, we don't want. Okay. We want the one which we preserved from the crash site. Okay. So our restore is over. Now I don't want this PG val which is recovered. So I am just removing that PG val and I will get back the PG val. So I will get back the PG val which was, so which I preserved. So the RMRF command is very, very dangerous command. Use it carefully. So if you don't give the correct target, so it might delete required files also. Remove PG val from restored data directory and so we are moving back that PG val. So I removed that PG val and I will move back. So the command is yumv. So you know where live. So PGSQL. So PG underscore val. So this one I want to move to where live PGSQL. So 14 data. So I want to move it to the data directory. Okay. So my PG val is also moved. I think, I am, the next step is to set the configuration and start. So next step is to set the recovery configuration and start the service. Create a file and start the service. Okay. So here I am opening the PostgreSQL.conf file. So I'm opening the PostgreSQL.conf file. So I will look for restore command. So restore command is right now empty. So I just need to put the reverse of. So reverse of what we say means the in archive command. So here what I'm doing is CP. So the command is CP from where right now my archive is in where live PGSQL ARCH. So percentage F. So this is the archive and I want to save it in the PG val directory. Okay. So PG val directory. This is the archive command I have set. And also I have uncommented restore command. So, you can see I set the restore command. I also uncommented the restore command. So, so archive cleanup command, I don't have any recovery end command, nothing recovery target. So So recovery target timeline, you can give this one as latest. Okay. So you can give recovery target because we want to recover everything. So if you don't want to recover everything, if you but you want to stop at a particular time, so you can give recovery target time here. So you need to give recovery target time. So these two changes I have done. I will save this file. grep. So restore underscore command. So this one I have set, and recovery target timeline, right? So recovery target timeline. Okay, these two changes I have done. Okay, I have uncommented recovery target timeline. I have uncommented restore command, and I have given the restore command, which is exactly opposite of, the archive command we had given. So, that is what, the recovery, that is what, I did. So after that, okay, I need to create a empty recovery.signal file. So a empty recovery.signal file I need to create. So how I am going to do is, so right now I am in the data directory. So I'm going to say touch. Okay. So where live PGSQL. So 14 data. Okay. Recovery dot signal. Make sure the spelling is correct. If the spelling is not correct, so recovery will not start. This presence of this file in the data directory, when you start the service, forces the Postgres go into the recovery mode and apply the archives if there is a restore command mentioned. Okay, so that recovery file is created. So recovery.signal file is created. So what we are going to do is, we are all set, just start the Postgres and check whether those changes are recovered or not. Okay, so the recovery.signal is created. Okay, start Postgres SQL service and verify recovery. That's it. So, you are doing nothing more than that. So, you are simply starting PGCTL start. Okay, there is a spelling mistake here. So the server has started. That means, the recovery has been done. So the actual thing is, so we should be able to see those changes we did, right? So we should be able to see the changes we did. So that is when we can accept that recovery is done. So you say PSQL P5433. So, and our table is, so which table we did the changes? Orders, right? So this table, oh, the recovery did not happen. Did we change the orders table only? Yeah, select star from orders. So we did in orders table only. I think, the recovery did not happen. So let's connect to MyDB. Okay, here also, the changes didn't come. Okay, somewhere I think I missed somewhere. Okay, anyways, what I will do is, so I will simply say PGCTL start and then start. Sometimes, it happens. Okay, so I think, we need to redo everything. Somewhere I missed, somewhere I didn't miss anything as far as see. I think I have copied back that file.
Did you copy back wall file?
I think so. I did it. Okay, this command is there which will copy back the PG wall. So I set the restore command where like PGSQL or cat postgres grep recovery target timeline. Okay, so I think I did it. So where I missed. You can see that the recovery.signal file is deleted right now. So if the recovery it has done the recovery, so generally it will delete the recovery.signal file. Okay. So let's do one thing. So let's Postgres. Let's stop it. And you remove that PG wall RF. PG wall. Okay, and oh, sorry, I did wrongly because I didn't have the copy of it. Anyways, we will perform the recovery one more time. So we'll perform the recovery one more time. But we lost the changes we did permanently. So permanently we lost those changes. So now the Postgres does not start. Postgres won't start right now. Anyways, I will copy back everything. We have the backup, nothing to worry. So, copy back everything. I have deleted the data directory. Then what I will do is simply I will untar it. tar-xf data. Okay. So the data directory is back. Okay. So I will put that configuration. CD data. So I will put the configuration vi PostgreSQL conf. So I will put the restore command. So copy where live PGSQL ARCH percentage F to percentage P. So this is the archive command. So where like PGSQL ARCH. Okay. So I will also give the recovery target timeline. So the recovery target timeline is so latest. Okay. So this one also we will uncomment, and instead of pass we will give okay, we'll give so what we say means shutdown or so this is what I am doing here. So I will start PGCTL start. So Postgres has started. Okay. So PS-P5433. So our tables, everything is there. Okay, our table, everything is there. But our orders table does not have the data because somehow we missed on that. Okay, our order table does not have the data. So what I will do now is, I will perform a fresh backup, and then I will perform the restore again. Okay, we have time, lot of time. So I will perform the fresh backup and I will perform the restore again. So right now, as our Postgres is working fine, so our Postgres is working fine. So we should be able to do a backup, fresh backup and a fresh restore. Okay. So I use the PG base backup. So I use the PG base, same base backup. I will just I will delete the old backup. So, and I have deleted the old backup. So completely old backup is deleted. Okay. So I will perform that same backup once again, PG base backup. So PG base backup I will perform. Okay, so I'm performing the base backup again for both the table space as well as our main data directory. Backup is over. Now I will make some changes to same repeat. So 5433. So I will repeat and then I will make some changes. Insert into orders, values 10, comma 20. So two values I am giving. Okay. Okay, I will connect to MyDB. Okay, so I made these changes, same changes by what I did earlier. Okay. So same changes I did, what those changes same changes I made now. Okay, what I am going to do is, so I can also switch the wall also if I want, but so it should pick up from the tail backup also if I do. Okay. Anyways, this time to be safe side, so I will switch the wall. So I'm also switching the wall. Select PG switch underscore wall. Okay, done. Exit. Okay. So now what I'm going to do is I'm going to crash and I'm going to restore pgctl stop. Okay, it is stopped. So I am going to restore. So what I'm going to do is data, I'm going to make it empty. Okay. So before that, I will preserve pg val. So pg val to the home directory of Postgres user. And then I'm saying, so rm-rf star. So everything is gone. Then what I will do is I will copy from, so I will copy from where live PGSQL. Okay. So 14 backup base star to the current directory. So everything is back. So I'll delete this PG val. So which is restored from the backup. So then I will copy back the PG val we have, okay, done earlier, CP, where live PGSQL val, so to this directory. Okay, PG val is back here, so which is the restored one. So from the crash site. So with this, so I will create a new file. So touch recovery.signal, recovery.signal. So this file is created. So now I will go into the PostgreSQL.1 file. So, and I will look for restore command. Okay, restore command is already set. and the timeline is also already set. So these things are already set. So it is time to start Postgres. Oh, so there is some problem here. Okay. Okay, so there is a backup.label file. So generally we restored it from the old thing, right? Backup.label file. So so just remove those. Okay, RM. So backup.star. So these files you remove. So there are no backup files. Now you start, PG based backup creates that files. Oops, still problem. So I think restored log file from archive, invalid restore manager ID in primary, could not leave valid checkpoint record. Startup process was terminated by signal abort. Okay, so so okay, this is invalid resource manager ID in primary checkpoint record. I think our PG wall directory is somewhat corrupted, I think. The wall directory is corrupted. So go to PG wall. So, you delete all these files, empty this directory. So I think there is some corruption in this directory. So, now you start, it should start properly. Oops. Okay, I think, some problem is there. I did some mistakes, I think, in showing you these. So, but the process I have shown is the same process which you need to do. Somehow it didn't work here. So invalid primary checkpoint record, panic could not locate valid checkpoint record. Okay, I think, some. So if it is empty, it will create a new wall directory. If it is empty, if the PG wall directory is empty, it will recreate it. Okay, I think what we'll do is we'll not waste any more time here. So I will look into what happened actually. So I think the steps I have shown, these steps are correct. So there is no question about these steps of recovery. You have to do stop the PG server and you need to empty the directories and you need to restore. So you need to restore and you need to, preserve the PG val. So restore from the PG val. So these steps are correct. There is no, this is the standard step, and I have performed recoveries using these steps many times. Somehow, it is not working right now. So it could be something, in the this thing I have done something so incorrectly, I think. So I need to verify what I did incorrectly. Okay. So what I did incorrectly. So I have removed everything. So So let me give one last try and then I will give up on this. I will demonstrate it to you guys tomorrow. Okay, just one last try. So I just created this and so one last try. So VI post. Restore command and I will just type that command real quick. CP. So I just changed this option to shut down. So that is the only change I did. So PGCTL start. So now it has started. Let's start from orders. Okay, it is not able to recover yet, but the thing is, so I will demonstrate this whole tomorrow. So I think I am doing something. So the process is same what I have explained here. So this is the same process which we need to do. But something it didn't work. So I will demonstrate it again tomorrow. Okay. So this topic, so we will repeat tomorrow. So right now, leaving aside this topic, so you can perform the backups and you can perform the base backup. You can enable archiving, perform base backup, and So you can perform the tar backups also. So that is what we do right now. So we will go to the lab and we will do the lab. So tomorrow I will repeat this topic. So this is what we will do now. So the topic, I will repeat the recovery topic. I will repeat tomorrow. Okay. So any questions here? Except that recovery. Okay, guys. Okay, I am assuming no questions. So we have half an hour. So you can set up archiving, perform base backup, and perform hard file system level backups. So recovery, we see tomorrow. So that's it. I will be at the desk. So if you need any help, so I'll be here to, okay. So yeah, I'll be going on mute. Okay, guys, see you guys tomorrow afternoon. So we are done for today. See you guys tomorrow afternoon. Tomorrow we'll learn barman. So most of the concepts we learned today. So tomorrow also we will so touch base on some of them. Yeah. So that's it from my side today. See you guys tomorrow.
Thanks, Ami. Bye-bye.